All right, Jacqueline. So let's have a look at your question. Click all. Here we go. So you're asking. You understand what you did wrong for the first one. Would be undefined within are less than zero. But how would I know the domain for that? Okay. So for the second question, let's have a look. I just need to roll back here. So your second question. Let's close that. Your second question, which is this one. Okay, you got. I should copy that one too. All right, so you have this question here, and you're basically, if you look at it, so there's a couple of things here. We call this a composite function because there are two types of functions within the one function, and this is the key thing right here. The key thing is you've got a hyperbola function right there. That's one function. You can call that g of x. And then you've got this second function where it's square root. It's square root of something. Okay, so that's a function. And then your second function is x minus 1, x plus 2. Okay, now both of them have conditions. So let's call that f of x and let's call that g of x, okay? So let's go back. I'm going to write over here. So let's say f of x is equal to root of something. Okay, and we know that the conditions for that would then mean it has to be all real numbers except for... Actually, it's not all real numbers. It is all positive numbers if it's a square root. Because it's a square root, it is r plus, including 0. Alright, so that's your condition for f of x. Whereas your second one, g of x, on the other hand, is an x minus 1 over x plus 2. Is that correct? Did I do that right? Yes. You see, this will then determine what values I can have. So g of x will end up in the y values, and then you'll be square rooting those values. Okay, so what you want to know is, well, domain would actually be based on what x values you can put into g of x, and that determines that you can still sub in f of x. So what I'm saying is the domain of g of x needs to also fit the domain for f of x. And we already know the domain for f of x is restricted to, it can only be all positive values including 0. So that means what you're looking for here is, well, when is the graph gonna allow for all positive real values including 0? That's what you're gonna be looking for, okay, in this g of x graph. So the question is, what does g of x look like? And you are meant to know what a g of x looks like because x minus 1, x plus 2, you can break that up and write that in another function. And if I break it up, okay, if I break it up for you, I already know the answer based looking at it, but I'm going to show you a couple of ways to analyze this. This technically, x here can be all real values, logically. Logically, x can be all real values, which also then implies that this can be all real values. But that's not true, because if x was actually equal to negative 2, what is the issue? Well, the issue is I have negative 2 minus 1 over negative 2 plus 2 actually ends up being negative 3 over 0, which we know is undefined. Okay, so that actually means no, it can't actually equal to negative 2, and it seems like it can be all real values. That's the idea. So what you're saying is it can be all real values. It can be all real values except for negative 2. But you also have to keep in mind that, well, no, actually, it can't be all real values. It has to be positive and including 0, but it can't be negative 2. Wait, hold on a second. Is that true? If it's negative 2, negative 3... Yeah, so you need this to be a positive graph. Did I answer that correctly? I think I did. So x minus 1 over x plus 2, if x is negative 2. Can I say it can be all real values? But then the other thing is you don't know if it may end up being a negative. Okay, you don't want it to be a negative. Okay, so it's not just this. This is the condition of the domain for this graph. But if we want it to be R plus union 0, what you're actually saying is you want the range of this graph to fit this. Okay, so this is the domain. I'm going to use another color. This is the domain of g of x. This is the range of g of x. And that's what you need it to fit in. Why do you need that to fit in? Because you're going to sub the range of g of x, which is the g of x values. You're going to sub it into the square root. Okay? So the question is, well, how do I make sure I'm going to get a range that's just only positive? So what you're saying is in the graph, you only want it to be 0 and above. That's what you're looking for. So the question is, what does the graph look like? Here we go. This is the alternative technique that I was going to show you. So x minus 1 over x plus 2. This actually is just a polynomial division. All you're saying is how many x plus 2's fit into x minus 1. I know I can say it goes into 1, so 1 times x will give you 1x. 1 times 2 gives you positive 2. The difference gives me negative 1 minus 2 is minus 3. So that tells me it's 1 whole minus 3 over x plus 2. Okay? And what does that graph look like? Well, that's just a hyperbola graph, if you think about it. This is just a hyperbola graph where you've got an asymptote at negative 2. And the graph has shifted up by 1. And it's a reflection, it's a negative. So I know the graph already looks like this. Okay? So what you're really needing to find right now is where, because remember I said you need the range of this graph to be greater than 0. So this is your range, this is your y values. Where is it? Where on the graph is it all positive? Well, this whole region here, from here to here, y values are positive or equal to 0, and all of that. Okay, so it seems that you need to find out this point here, this selection, that coordinate there. You need to find the x-intercept of g of x. So remember, this is g of x. G of x is x minus 1 over x plus 2, which I've rewritten as 1 minus 3x plus 2. And what you want is you want g of x to be that pink highlighter that I've just done. Okay, that's what you want g of x to be. So in order for that to occur, you need a domain. So what x values will give you that pink? And I'm going to highlight the x-axis in green so you can see which areas I want. This is what I want. See, from there to there onwards, g of x is going to be greater than or equal to 0. Same thing here. What I don't want is the area I didn't highlight in green. Okay, so that's my domain. So you need to find the x-intercept. Now you know the x-intercept occurs when y is equal to 0. So if g of x equals to 0, you got 1 minus 3 of x plus 2. Bring the 1 across, equals negative 3x plus 2. And then you times both sides by negative, and then that becomes 1 equals 3 over x plus 2. Times both sides by x plus 2, and you get x plus 2 equals to 3. And then x equals to 1. That doesn't make sense. Actually, it does make sense. So that means the graph actually looks like this. So it has an asymptote at negative 2, asymptote at y equals 1, and this is what the graph looks like. So looks like that, where it crosses at 1, and this is my other graph. There you go. So what's my domain? My domain seems that it has to be from 1 onwards and less than negative 2. So the domain such that g of x will still be okay. Okay, so think about it again. Let's go back to recapping what we're saying. We said that it needs to be positive. We need it to be positive, including 0. But that is affecting g of x. G of x will be the one that I'll be subbing in here. So I need g of x to be r plus union 0. Now g of x is technically your y value, so that's why I was focusing on the graph, and I was saying, all right, I need g of x to be r plus union 0, and this is where it is. This is the graph where it's r plus union 0, because this is my y-axis, yeah? Those are my y values. This is when it's 0 onwards, r plus union 0. I needed to know the domain. So I've worked out the x-intercept, and from there I can already tell you the domain needs to be or negative infinity all the way up to 2, not including, union, okay, including 2, because it's okay to have 0, not including 2, it's including 1, because that's the x-intercept, including 1 all the way to positive infinity. Yeah? Does that make sense? If I look back at your equation of your graph, we can see, I don't need to know what the graph looks like, but I was correct in the sense to say that this region shouldn't exist. You can't need that region. You see, without even looking at the equation, I didn't even draw the graph. I didn't even draw the proper graph. See, all I drew was the components that made that graph. I drew a hyperbola function, which we've learnt in chapter 5 of year 11 textbook. Okay, and I looked at the properties of a square root function, which again is in the chapter 5 year 11 book. And I pieced those together and I'm able to find the implied domain. And now I know that is hard. That is chapter 1 of next year, and it's in composite functions. It's a hard concept because you're analyzing the function. That's the whole point. You're actually reading what the equation wants you to do. What can it be and what it can't be. It generally takes me a while to teach that. So hopefully you can take out what I'm saying. Hopefully it makes sense. I might have not explained it too well, but hopefully it did. Okay, hopefully it was good enough for you to sort of get a feel. So I'll just do, again, a recap again, so that you can see everything and sort of put it together. So the idea was you had h of x equals the square root of x minus 1, x plus 2. I extrapolated this into two functions. I said, all right, you had f of x, which is the square root of something, and then you have g of x, which is x minus 1 over x plus 2, right? What I knew was this was the issue. It could be all real numbers except it's all real numbers that's positive and including 0. Okay, that's what I knew. Now the thing is, this will be dictating what that is. So what I need is, I need this to also be r plus union 0. Now a lot of the times the students make mistakes is they think the domain of g of x needs to be this. No. You see, because you're actually subbing g of x in here. G of x, remember, g of x is actually equal to x minus 1 over x plus 2. So technically this is your y values. So you're actually wanting your range to be r plus union 0. Okay, that's why I drew the graph of g of x. So g of x is this, and I drew the graph and I found out this is what it looks like. So you're meant to know how to sketch a hyperbola function, and I found out the x-intercepts, and I found out that it must look something like this. So from there, where is it r plus union 0 for my range? Well, r plus union 0 would tell me it's this region to that region. That's how I get my domain. Okay, and that's how I get the domain of g of x, because that will dictate what the domain of f of x can be. Okay, and that's actually one of the properties. It will say domain of f of g will be the domain of g of x, but I don't want to talk too much about that. That's for next year. But if you can read up on it and understand it, this is where all the theory comes from. That's where all the logic comes from. Okay, so I just quickly summarized it there for you. Replay it if you have to. It does take time to understand.